Okay, this is P.7 day 2. The assignment is here. Notice that they're all even numbers all the way through. Okay, in solving absolute values equations, basically what they're saying is that this number, whatever it happens to be, the absolute value of it is 18. So this number itself that's represented by this expression 4x minus 2, this could be absolute value of 18, which is 18, or this could be the absolute value of negative 18, which is 18. So that means that whatever this expression is, it's either 18 or 4x minus 2 is a negative 18. So those are the two situations that would make this original statement true. So if I solve them out, 20, sorry, and then divide by 4 here, I would have a value of x being possibly equal to 5. Or solving this one, I would have a value of x being equal to negative 4. So since we don't have any more information to determine exactly which one it is, we simply say that they both could be our answer. Now, number 2, example 2, this is telling us the absolute value is negative 9. Well, the absolute value are always positive answers, so it's not possible to take the absolute value of something and get the answer to be equal to negative 9. So whenever you see this, look out for this. This is a tricky type of a question. If you ever see this, you simply have to try to recognize it right away and say, aha, that is undefined. It doesn't exist. There's no way that could be true. An absolute value cannot equal a negative. All right, example 3. Well, first we have to isolate the absolute value, which means that we want to get this section right here in between the bars all by itself on the left side of the equation. So I'm first going to add 20 on both sides. And then, you may not think to do this, but we can actually divide by 4, because this is 4 times this stuff here. So if I divide by 4 here, doing it on both sides, I get to cancel it, like that. So, absolute value of 1 minus 2x equals 5. Now this looks a lot like example 1. We started with a quantity inside an absolute value. It equaled something positive. That can be taken to the next step further and said, okay, that must mean whatever this is inside the absolute value bars is either positive 5, because the absolute value of positive 5 is 5, or all the stuff inside the absolute value bars is negative 5, because the absolute value of negative 5 is also positive 5. So those are my two options. I'm going to assume now that 1 minus 2x is a positive 5, or 1 minus 2x is a negative 5. So I would subtract 1 on both sides, divide by negative 2, which gives me my first answer of x being negative 2. Or if I subtract 1 on both sides here, divide by negative 2 here, I get positive 3. Now, the last example, number 4, is not absolute value. It has to do with radicals. There's that one. And one more time. Now you're going to notice that example number 3 and example number 4 are very similar. The first thing we want to do, just like we did with number 3, is to isolate the expression that allows us to take the next step. So like right here, we have a radical, that's the square root. We want to get that part right there all by itself. So how do we do that? Well, making this a little brighter for everybody, we simply need to get rid of this plus 3, okay? So if we move that over to the other side, we can do that by subtracting. I would have this isolated all by itself, and over here I'd have x minus 3. The reason why I wanted to get this all by itself is I want to get rid of that square root symbol. How do you get rid of a square root symbol? Well, you just square both sides. So I'm going to take this side of the equation and square it. And this side, notice I'm putting that in parentheses and squaring it. Just like you can take the square root of both sides, you can square both sides. So this radical square root cancels with the square, and on this side I just get x plus 3. Now on this side, x minus 3 quantity squared is x minus 3 times itself. And if I FOIL that out, I get first, outer, inner, last. Obviously I can add those two together, which gives me negative 6x plus 9. But now what do I do? Well, what I want to do is I want to get everything over onto one side of the equals. So I'm going to move everything over here to the right because there's 3 terms here and 2 terms there. It'll just be easier to move them these two over there. So if I subtract x on both sides and I also subtract 3 on both sides, I get a 0 over there, which is what I want. Now we have a simple quadratic over here, and it turns out this is factorable. So we're looking for two numbers that add together to be negative 7, but multiply together to be positive 6, and those numbers would be negative 6 and negative 1. So my two factors are x minus 6 and x minus 1. Now, to finally solve this and figure out what my x answers are, I would simply set x minus 6 equal to 0 and x minus 1 equal to 0, and then solve. So that gives me x equals 6 and x equals 1. Now, here's the thing. We need to check this answer to see if it's true. Now, we didn't have to check these over here because in absolute value problems, there is no undefined values other than this circumstance. Okay? Here, we can actually come up with answers that don't work, and we may not know it. So here's what we're going to do. We're going to check to see if 6 could work. Can 6 work? Let's see. If x is 6, that would be the square root of 6 plus 3 equals 6. Is that true? Is the square root of 9 plus 3 equal to 6? Is 3 plus 3 equals 6? Yes, 6 equals 6. So the answer, x equals 6, works. It gives you a true statement. That's yes. So I'm going to put a box around my x equals 6. That's a workable answer. Now let's try the number 1 and see what happens. You might be surprised. Taking the square root of 1 plus 3 equals 1. The square root of 4 is 2. 2 plus 3 is 5. Does 5 equal 1? No. What? No, that's false. So x equals 1 down here is not a valid answer. And only checking that we would know. So I'm going to cross that off and only use x equals 6 as my answer.